previous part of this talk, I discussed the geological and hydrogeological conceptual model and behavior for a contaminated site. But before moving to the analysis of the pollution, we have also to consider the problem about hydrodynamic system. The movement of groundwater has to be considered taking into account the human pressure and the modification due, for example, to the pump and treat system. For analyze the hydrodynamic characterization and the relationship between the shallow part of the aquifer, the effect of the pumping rate, one of the powerful instruments can be the flow meter test. So we use a heat pulse flow meter for evaluate vertical component on groundwater flow into the system, into the shallow one and into the deep one and to the aquifer system. So in the entire aquifer we consider to verify if the activity of the pumping system can affect also groundwater flow direction and velocity, as we can imagine when you realize a pump and treat system. So the flow meter test has been conducted in several piezometers, in several monitoring wells, to verify if it's possible to have vertical flow into the system due to the existence of the heterogeneity or to human pressure by pumping rate. In porous aquifer, vertical components of flow are due to vertical heterogeneity, and in multi-layer aquifers it's possible to measure vertical flow where aquifers also are present. In general, the results of the flow meter test can also indicate if the situation up gradient or down gradient of the physical barrier is in agreement with your conceptual model, and it can also indicate if your hydraulic barrier, your pump and treat system is working well. The results of all this information, including the water table monitoring, allow us to identify the groundwater flow system with a high detail, and as you can see, the groundwater moves from the up gradient area to the shoreline, but is really affected close to the physical barrier, close to the pumping system, by the pumping rate of the wells, of course. What about the piezometric change with time? If you look at some piezometric recording in the water table recording into the the monitoring well located up gradient clearly show a seasonal effect, which means that inside the petrochemical plant, but far from the pumping wells, there is an influence due to the normal seasonal effect. But if you look at the results close to the pumping area, close to the shoreline, where the water table is decreasing, the main effect is due to the pumping, and the seasonal changes are very, very small, of course, because of the pumping system effect. So we can register different situations, and we also can test the efficiency of the hydraulic barrier, taking into account the evolution with time for the beginning of the remediation activity until now of the piezometric and the water table level into the monitoring well. The next problem we have to face is about the intrusion, the marine intrusion due to the pumping system, which can of course reclaim salt groundwater from the shoreline. And in some cases we register this kind of situation with the intrusion of the marine water into the aquifer. The best way to verify where is located the interface between shallow freshwater and saline marine groundwater are represented by profile log, vertical log of the electric conductivity. And sometimes we can identify the interface about 15 meters from ground level. Sometimes this interface is located 5 meters below the ground level, and sometimes we also verify that this interface is very close to the ground. And we reconstruct the depth of this interface, which of course is influenced by the pumping in the petrochemical plant. As you can see, there is two important parts where the marine intrusion can be affect significantly the groundwater flow and the groundwater system, where the interface is located less than 10 meters from the ground surface. In other parts of the aquifer, of course, this interface is located about from 20 to 30 meters respect to the ground surface, which means that marine intrusion is not so important in this case. But we have not only marine intrusion, because in the plant there is a channel that is used from the industrial purposes, which tap the water from the sea, and this channel is not really disconnected respect to the groundwater flow. So the channel and the pipelines into the petrochemical plants can lose water into the groundwater system. And of course, when you start to pump by your remediation system, these losses can be enhanced by the lowering of the groundwater table. In this case, we monitor the electric conductivity very close to the channel, and we discovered that with depth we have different situation, of course. Sometimes the depth of the marine intrusion system is very close to the surface. The seawater canal effect include a high salinity water that spreads into the aquifer, and we realize an impermeabilization project to reduce these losses and of course the salinity of the shallow aquifer. As you can see, in some cases, for example in this monitoring well AMW4, the electric conductivity greatly reduced from 2007 to 2008 and 10 to 2012 after the impermeabilization process. So the monitoring, the vertical log of the hydraulic or the electric conductivity can be very useful to verify the efficiency of the activity you realized in this case. The physical barrier and the pumping system create also a stagnation zone located down gradient of the physical barrier. And we also register this situation of stagnation zone by a vertical log of the electric conductivity. So we can evaluate that without the stagnation zone, the groundwater can flow from back from down gradient to the pumping well, passing below the physical barrier. But where the groundwater, the marine groundwater has been reclaimed by the pumping wells, we can have a sort of stagnation zone down gradient of the physical barrier. The stagnation zone can be considered as an effect of the hydrodynamic of the remediation system. So moving from up gradient to down gradient, you can see this kind of the hydrodynamic situation with the marine intrusion passing after below the physical barrier, reaching the pumping wells, and the groundwater located in this area is not able to be called back to the pumping system. We use also environmental isotopes to identify the different sources of groundwater into this aquifer, taking into account this complex hydrodynamic situation. And we identified the typical megasite groundwater related to the normal, natural aquifer. We also verified the existence of a groundwater affected by seawater intrusion, and of course there is a mixing area where some monitoring wells include a portion of the natural groundwater and a portion of the seawater intrusion. But we also identified a very depleted value due to the losses from leaking pipes that also have an additional effect on the hydrodynamic system of this area. So in where you have an industrial area, like a petrochemical plant, not only the pollution has to be taken into account, but also water losses, which can recharge your aquifer with a different kind of water.